Good morning everyone. Today we are going to study about how to write a short note on pacemaker potential. Before writing about the pacemaker potential, you have to write a short introduction. Heart has a special system for rhythmic self-excitation and repetitive contraction. They generate electrical impulses to initiate rhythmical contraction of heart muscle and conducts these impulses rapidly through the heart. Property of cardiac muscle that enables the heart to initiate its own impulse at constant rhythmical interval is called autorhythmicity. So pacemaker potential explains the phenomenon of autorhythmicity. Auto means self. So that is automatic rhythmical discharge and contraction. This is due to SA node or sinus node which act as a pacemaker tissue that initiates the action potential. SA node discharges most rapidly and depolarization spreads from it to other regions of the heart before they discharge spontaneously. So because of its rapid action, this SA node is known as cardiac pacemaker. Spontaneous rhythmical electrical impulses arise from it and spread in all directions. This property of SA node is due to its pacemaker potential. Now we'll move on to pacemaker potential. So after each impulse, the membrane potential declines to the firing level. So this is the firing level that will trigger the next impulse. Okay, so this is the starting point of pre-potential or pacemaker potential. So from this point to this point, this phase is known as pre-potential or pacemaker potential, which triggers the next impulse. Moving on to ionic basis of pacemaker potential. Resting membrane potential of SA nodal muscle fiber between discharges is minus 55 to minus 60. So they have labeled here minus 60 as the resting membrane potential. Now, at the peak of each action potential, so this is the action potential. So this is the peak of action potential. Okay, at the peak of action potential, the potassium channel opens, leading to potassium efflux and causes repolarization, and now the membrane potential reaches the base. Now another channel known as F channel or H channel is activated. This channel is permeable to both sodium and potassium, but sodium influx dominates. This causes a slow rise in resting membrane potential, which forms the first part of the pre-potential. So you know this phase, that is starting from this point up to this point, is the pre-potential, and the initial half or the starting of pre-potential is made by this opening of the F channel or H channel leading to sodium influx. And because of the sodium influx, you can see the resting membrane potential is rising towards the positive side. Why this channel is called F channel or H channel? F means funny because of its unusual activation during hyperpolarization, because usually sodium channel is activated during depolarization, but here you can see this is in a hyperpolarized state, and during this state there is opening of the sodium channels, so which is found unusual and funny. Okay, because of its opening during hyperpolarization, it is known as H channel, and because of its funny nature or unusual nature, it is known as F channel, and the current produced is called funny current. And this forms the first part of the pre-potential. Next, calcium influx happens due to opening of the transient calcium channel, and this completes the pre-potential. So initial half of pre-potential was caused by opening of the funny channel leading to sodium influx, and the final half of the pre-potential was caused by calcium influx caused by opening of the transient calcium channel. And also local calcium release from sarcoplasmic reticulum also happens during pre-potential, which is known as calcium spark. So three mechanisms, that is sodium influx due to opening of the funny channel, calcium influx due to opening of the transient calcium channel, and calcium spark. contribute to the pre-potential. And now the resting potential is gradually rising and it becomes less negative. It is moving towards positive from minus 60. When the potential reaches a threshold voltage of minus 40 millivolt, L-type calcium channel opens, leading to calcium influx, resulting in action potential. So till here it will be called as pre-potential or pacemaker potential, and now at this point they have reached the threshold potential of minus 40 millivolt, which results in the opening of L-type calcium channel, leading to action potential. Now, as I have already said, at the peak of the action potential, there will be opening of the potassium channel, leading to potassium efflux, leading to repolarization, and the membrane potential reaches the baseline, which will again trigger the next impulse by opening of the funny channel, leading to sodium influx. Moving on to effect of autonomic nervous system on pacemaker potential. SA node is innervated by both sympathetic and parasympathetic fibers. So first we will study about parasympathetic stimulation. When cholinergic vagal fibers, that is parasympathetic fibers, are stimulated, membrane becomes hyperpolarized and slope of potential is decreased. So in this diagram you can see this is a normal prepotential. This is the normal slope of the prepotential. Now when there is vagal stimulation, you can see the slope of the prepotential is decreased. What is the reason? Acetylcholine is a neurotransmitter. So when acetylcholine is released at the nerve endings, there will be increased potassium conductance of the SA nodal tissue. This is mediated by M2 muscarinic receptors that opens a special set of potassium channel, leading to potassium efflux. At the same time, it also decreases the cyclic AMP in the cells, which slows the opening of L-type calcium channel. So both this mechanism will result in decreased firing rate. So you can see when there is vagal stimulation, there is opening of special set of potassium channel, leading to potassium efflux, and delayed opening of the L-type calcium channel. So the slope is decreased. And when there is stimulation of sympathetic nerves, the neurotransmitter norepinephrine released from it will bind to beta-1 receptors and increases the intracellular cyclic AMP. This facilitates the opening of L-type calcium channel, increasing the calcium influx and leading to depolarization. So you can see this is the normal slope of the prepotential, and when there is sympathetic stimulation, the slope of the prepotential is increased. So when you get a question like write a short note on pacemaker potential, you have to start with an introduction describing about autorhythmicity. Then you have to write the ionic basis of pacemaker potential along with a neat labeled diagram. Then you have to write the effect of autonomic nervous system on the pacemaker potential, describing both sympathetic and parasympathetic stimulation along with the diagram. Hope it's clear. Thank you.